Hey guys, it's Mr. C, and in this video we're going to look at some modeling with functions. And so we've got two problems here that we're going to do. We're going to take a real world problem and we're going to model it with a function and a table of values, and then we're going to see what happens. All right, so problem number one says the cost of sending M text messages at $0.25, which is 25 cents, per message can be represented by the function C of M, and C probably stands for cost. That's a function notation. C of M, M would probably be messages, equals 0.25 M. So we're giving you the function here. It says to complete the table for the given domain values. So we have our domain over here for the independent variable, and over here we have the ordered pair that's going to be created when we plug in these numbers for our function notation. So we're going to do that in the middle part. And so we already have the first one given to us. When M is 0, then 0.25 times 0 is still 0. And so we get the ordered pair 0, 0. And that makes sense because if you don't send any text messages, then you're not going to be charged any cost, any money. So it makes sense that 0, 0 would be one of the ordered pairs. So if I look down here at my graph, I'm going to have to take this and move it down here at some point. So let's go ahead and get this first, and then we'll translate it to our graph down there. All right, so for one text message, 0.25 times 1 equals 0.25. So the ordered pair that's created is 1 comma, because remember, 1 went in for M, right? Is going to be 1 comma 0.25. All right, let's do 2. 0.25 times 2 equals 0.25 times 2 is 0.50, which is 50 cents in our problem. So we have the ordered pair 2 comma 0.50. If you want to, you could just write 0.5. You can drop that extra decimal 0. It doesn't matter. Third one, 0.25 times 3 for 3 text messages. So if we multiply that, we get 0.75, which is going to make the ordered pair 3 comma 0.75. And finally for the fourth one, and you could keep going, but for the fourth one you got 0.25 times 4. And if you multiply 0.5 times 4, you get 1.0. 1.00, that's $1. And so we get 4 comma, you could write 1, you could write 1.00. I'm just going to write 1.00 just to be consistent. So we have our table made, and now what we need to do is we're going to create this graph down here. Now the graph is absolutely blank, and all it shows is quadrant 1 right here, because we don't need any of the quadrants because everything's positive. So what we need to do though is we need to label our axes and label our scale so that we know what's going on here. So we're only going from 1 to 4 down here, right? And so what's this variable? This variable is M. Those are the messages. Up here, that's C of M. Remember, it used to be Y, but now we're calling it this function. So that's going to be C of M up there. And then we got M down here. And so now let's label our axes. We only have 4 text messages. So we could actually, if we want to, we could start 0, and then we could skip 2 spaces and probably be able to get that in. 0, 1, 2, 3, 4. We could do it like that. So 0, 1, 2, 3, 4. We could get them all in there. This one, we're only going from 25 cents to $1. And so all of these, what we could do is we could go 1, 2, 3, 4, 0.5. 1, 2, 3, 4, 1.0, and then we can capture all of those function C of M values, those Y values we used to call them on that axis. So what we do then is we go ahead and we plot some ordered pairs. So 0, 0 would be right here. 1, 0.25, 1, and 0.25 is halfway between 0 and 0.5, so that's here. 2, 0.5 would be here. 3, 0.75 would be right there. And 4, 1.0 would be right here. And so what we do is we want to create this pattern that will show us the behavior of this function. And then we can get any one we want after that because we already see how the pattern's going, and we could find 5, 6, 7, 8, 9 easily by just using this graph. But that's how you model this function with a table of values, get your ordered pairs, and then graph the ordered pairs on a blank grid. All right, let's do one more. So in this one, it says Ben wants to tile part of a floor with 36 square tiles. The tiles come in whole number side lengths, that's nice, from 2 to 6 inches. If S is the side length of a tile, the area he can cover is A of S, and A probably stands for area. A of S is equal to 36S squared. Complete the table for the given domain values. All right, so our independent variable, where are we gonna start here? Well, it says from 2 to 6 inches for our domain. Our domain isn't gonna go from start 0 because the side lengths don't have 0, right? You're not gonna have a tile with a 0-inch side length. So it's only 2 to 6. So we're gonna start 2, 3, 4, 5, 6. So that's our implied domain. We have to know how to put those numbers in for our domain. Then each one of these, we're gonna square and then multiply by 36 to get our ordered pairs over here. All right, so that's what we have to do in the middle part. So A sub 2 would be 36 times 2 squared. Okay, so what I'm gonna do is I'm gonna calculate these. 2 squared is 4, and 4 times 36 is 144. That's gonna give us the ordered pair of 2, 144. All right, so 3, 36 times 3 squared. Okay, 3 squared is 9, 9 times 36 is 324. And so we have the ordered pair 3, 324. Kind of big numbers, but it is what it is. 4, 36 times 4 squared. 4 squared is 16. 16 times 36 is 576. So we have 4, 576. Okay, same thing for 5. 36 times 5 squared for that tile. 5 squared is 25 times 36 is going to be 900. And so we have 5, 900. And then we have 6, so 36 times 6 squared. 6 squared is 36, and 36 times another 36 is 1296. And so we have 6, 1296 as our final order pair. So we have to put all of that down here on this grid. All right, so this is gonna be a little challenging. So we have, first of all, S for side length is our independent variable, and the dependent variable, which used to be Y, we're calling A of S, area of S. Okay, so now we need to label our grid right here. So probably here, what we need to do is go by ones. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, we're only gonna really be 2 to 6. So all of this is gonna be blank, and then this is gonna be blank too right there, because we're only gonna do 2 to 6. This one's interesting though, because we don't know how many to go by. What I'm gonna do is I'm gonna have each one of these marks here be 150. So 300, and then I'll skip 1, 600, skip 1, 900, skip 1, 1200, skip 1, 1500. You want to make sure when you label this that you can capture all of these Y values, and 1500 is well above 1296, so I'll be able to capture that. I'll just have to kind of guesstimate. I won't be able to plot the point exactly. I'll just have to make an educated guess as to where it is. All right, so 2, 144. Okay, so here's 2, and I need 144. So this is 150, so 144 is right below 150. 3, 324. 324 is going to be probably about right here. Not too far above, but about right there. Oh, I put it in the wrong place, didn't I? 3. I do that all the time. So if that happens, I'm using a pen, I should use pencil. Just X that one out. 4 is going to be 576. So that's going to be almost up to 600. Looks really bad now, doesn't it, with that there, but that's okay. If I had some white out, I'd get rid of it, but I don't, so that's okay. 5 is going to be at 900, so exactly right there. That's nice. And 6, our last one, is at 1296, so that's probably going to be about right here in the middle a little bit, about right there. Okay, so all you're supposed to do for this is observe the pattern, and we can see that as the side length goes up, the graph goes up tremendously, and it's going to keep going up in that kind of curvy pattern like that we're going to learn later. So when you're modeling with functions, table of values, then you're going to put them onto a graph and then display them with the graph, and that is your problem number 2. So modeling with functions, remember to like my video and subscribe to my channel, and we'll see you guys later. Bye.